All right, let's dive into K5. If you're a data engineer, this is a core standard you absolutely need to know. It covers data quality, ethics, the whole shebang. But it all boils down to one really big idea: data is never neutral. It's packed with risks, and it's our job to handle them. So let's talk about how you make your data something you can actually trust. And you better believe it. Think about it. A single missing value, a data set from some sketchy source, any weak link in that chain can cause some serious real-world damage. We're talking wrecked models, angry customers, and yeah, even getting your company into legal hot water. So how do we stop that from happening? To make all this a bit more real, let's use a case study. We'll call them Hungry Now. You know the type, a food delivery app. They've got an app for customers, a system for drivers, dashboards for restaurants, and the whole thing is powered by data. And as you're about to see, every single piece of it is a potential landmine for data risk. So where do things usually go sideways? Well, it turns out there are a few common ways data can, let's say, fail us. We're going to break down the 6 main data risks that a company like Hungry Now is up against pretty much every day. Okay, here's the rogues gallery. You've got everything from incomplete data causing deliveries to fail, all the way to unethical data just destroying customer trust. But here's the key takeaway, the thing you have to see. There's a direct line connecting every single technical problem to a very real and often very painful business problem. Let's start with the classic, the one you'll see everywhere: incomplete data. A missing postcode isn't just a null value in a database somewhere. For Hungry Now, that null value means a driver is lost, the food is getting cold, the customer is getting angry, and the company is losing money. It's really that simple and that damaging. Now for something a little more sneaky: bias. So imagine Hungry Now builds this shiny new AI recommendation engine. But whoops, it was mostly trained on orders from London. Well, guess what? The app is now basically useless for everyone else. If you're in Manchester, you're getting recommendations for restaurants you've never heard of. That's not a cool, personalized experience. It's just broken. Okay, so we've diagnosed the problems, and that might seem a little grim, but here's the good news. We're engineers. We build things. We can actually engineer defenses against this stuff. This isn't about just crossing our fingers and hoping for good data. It's about building pipelines that demand it. If you think about a typical data pipeline, it's got these 4 key stages. You can think of them as checkpoints, really. And at every single checkpoint, we have a chance to build in some controls, from the second the data hits our door at ingest to the moment we serve it up in an app. Here's a perfect example of a first line of defense, right at the front gate. This one little line of SQL is basically telling our database, hey, do not, under any circumstances, let a new restaurant in here if it doesn't have a postcode. It's a dead simple rule that stops thousands of potential failed deliveries before they can even happen. Now we can get even smarter. It's one thing to check if a value is missing, but what if it's there but just plain wrong? Using a tool like Great Expectations, we can check for business logic. We're telling the system, look, a delivery can't take -5 minutes, and it probably shouldn't take 6 hours. This is how you catch those weird inaccurate values that a simple not null check would miss completely. So what happens when we do find bad data? We don't just delete it. That's like throwing away evidence at a crime scene. No, we quarantine it. This code gives you the basic idea. We split the good from the bad, move the bad rows to a special penalty box table so we can analyze them, and then automatically send an alert to the team. We're not just finding the problem, we're creating a trail to fix it for good. Building those technical guardrails is absolutely crucial, but our responsibility as engineers doesn't stop there. K5 really pushes us to think bigger. You know, it forces us to consider the ethical side of the data we're using and the hidden biases that might be lurking inside it. And this brings us to a super important concept: data provenance. It sounds a little fancy, but all it means is the data's life story. Where did it come from? Who touched it? When was it last updated? Without that audit trail, you can't really trust your data because you have no idea if it's reliable or if it was sourced ethically. And this right here is the golden rule. As a data engineer, you're a gatekeeper. You are the bouncer at the club. So if someone comes to you with a data set of competitor info that they, scraped without permission, your job is to say no. If you can't verify where a data set came from, you can't vouch for it, so you don't let it in your pipeline, period. The crucial thing to realize is that we can and we absolutely should measure bias. This isn't just a vague feeling, it's a number we can track. This chart for Hungry Now is a massive red flag. 94% accuracy in London, but only 71% in Manchester? That tells us our model isn't just a little off, it's fundamentally failing an entire city of users, all because our training data was lopsided. You can't just set up all these awesome checks and then walk away. Data is a living, breathing thing. It's always changing. New sources pop up, APIs change, bugs get introduced. That means data quality is not a project you finish, it's a continuous process. You have to monitor, respond, and repeat. And the best way to do that is with a live data quality dashboard. Just picture this on a big screen in the office. We're tracking our data's vital signs in real time. First up, completeness. Are we missing stuff? 99.1%. Okay, that's looking pretty solid. Next up, accuracy. Is the data that we do have plausible? Does it make sense? 98.4%. All right, we're still in good shape. And then maybe the most important number of all, open incidents. Seeing a 1 here isn't a failure. It's a sign of success. It means our monitoring system is actually working. It caught something, it created an alert, and now somebody needs to take action. And when that alert pops up, we don't panic. We follow the plan, the runbook. We've got a clear 5-step process. We detect the problem, we figure out how bad it is, we dig in to find the root cause, we fix it, and then, and this is the most important part, we add a new check to make sure it can never happen again. This is how the system gets smarter over time. So we've covered a ton of ground here, from simple SQL constraints to big ethical frameworks. So why should you, as a data engineer, care so deeply about all of this? It's simple, really. This stuff is what separates a good data engineer from a truly great one. Look, this is exactly how you show that you've mastered K5, especially in your endpoint assessment. You don't just want to say, I built a pipeline. You want to use powerful, precise statements like these. You show that you didn't just write code. You thought about risk, you built specific controls, you upheld ethical standards, and you measured your impact. This is how you prove your value. And that brings us to the one big question you should be asking yourself every single day. Is your data an asset that's driving the business forward? Or is it a ticking time bomb, a liability waiting to go off? The difference between the two is a data engineer who truly understands and applies the principles of K5. The choice is yours.